Welcome to edgeo.com, a product of Real Time Signals Private Limited. Today let's talk about single pointers. So this is a topic in C language that gave an illusion that C is difficult for beginners. So let's get into this. So let's initialize a variable as I and its data type is an integer. Say int I is equal to 25, and this is how it will acquire space in a memory location. The memory location is named as FA10, not named, it got allotted as FA10, and 25 has been put into that space. So how do you declare a pointer? We said pi is a pointer. The star qualifies pi to be a pointer, and it says that it is going to take an address, and the prefix says that data type of which address it is going to take. In our case, pi is a pointer. It's going to take an address of an integer. I is an integer. It takes the address of I. So here is how pi is been allocated with. Pi takes the address of I, that is FA10, and pi itself has an address called 1A5. So let's get into next of it. So the image is showing you the address that has been allocated. So let's get into this, a new example where x is having a value called 9879 and px is a pointer, and it is going to take an address of an integer. So x is an integer, and so it took an address of x. So this is the block diagram or representation of it. When you print x, what will we get? We will get the value, expected value is 9879. Yes, this is the value that you got. So if you are trying to print address of x, you will get a decimal value of it. This is 1019. So the decimal equivalent of 9f is 1010. If you're trying to print what is px, you will get 9f, what is there inside. So that is decimal value is 1010. And if you're trying to print pointer of px, you will get the actual value that got stored in that address. So let's go back to Dave C++, and I'll show you a practical implementation of it. So let's start writing the code. Int include .h. This is the standard header file that has been included. Int main, this is the main function. Let's take a pointer ptr. I say ptr is a pointer. It means ptr is going to take an address. It can take only an address now. So you will have to prescribe whose address it is going to take, which kind of data type. Let's say it is going to take an address of an integer. Equate that space to null. You are just nullifying that space. And let's take an integer, int a is equal to 98. Follow it down. So ptr is going to take an address of a, and let's try to print it. Printf %d is the value, and you see when you do pointer ptr, it will give you what is in a. It will tell you what is in a. Let's compile this and run it, and you saw that I just printed pointer ptr. I got 98. Okay, let's get into something called as double pointer. Let's make one more pointer. I said ptr1 is a pointer, meaning, as I said you before, it is going to take an address, and you will have to prescribe whose address it is going to take. So it is going to take an address of an integer pointer. So in our code, who is an integer pointer? PTR is an integer pointer. Yes, PTR is an integer pointer. So we say PTR1 is equal to address of PTR. Yes, this is how we can assign the value to it. So let's try to printf and see %d as the value of PTR1. Let's check what happens when you do pointer PTR1. When you do pointer PTR1, let's put a /n for the next line, not to make you confused. So when I do pointer PTR1, it will give me address of PTR. This is the address of PTR. And when I do double pointer of it, it will give me what was there in PTR. Can you see this? This is what is double pointer. Likewise, you can make triple pointer. Do you want to see how does a triple pointer work? Let's say PTR2 is a pointer. It's a pointer to a, if it is a pointer, it will take an address. You will have to tell whose address it is going to take. It's going to take an address of a double pointer. So let's put brackets. Now in our code, who is a double pointer? Who is a double pointer? So PTR2 can take an address of a double pointer. PTR2 is equal to address of PTR1. Okay, so let's printf and see %d is the new value of triple pointer. So let's do star of PTR2 and you will get the value again. You see this is what is triple pointer. So likewise, you need not to get confused. It's very easy. And let's get into other part of it. Hope you understood the basics of pointers. So let's try to write a code, an example where pointer is used. Let's try to write. I will write an array, integer array of 3 elements, and those 3 elements are 1, 34, thus, and let's transfer it to a function. I have a function void call bracket. I said integer pointer is my argument. Let's take a pointer. PTR is the pointer. So PTR is a variable name. You can give any name to it. Is a pointer to an integer is assigned to null. I said PTR is equal to address of array of 0. It is taking the address of the first element of the array. Let's call the function of with an argument of a pointer. PTR is a pointer. I am sending it. Let's write the function's definition. Just copy it with the prototype function definition, and you should have a variable to hold it. We say for I is equal to 0, I is less than 3 elements. This is a for loop wherein let's print which percentage d I am talking about. I am talking about star h in our case. and let's increment h every cycle. So it will ask who is I, so int I. So let's talk about this. What will happen? The code will run from the top, and it will allocate an array and put data into that. It has 3 elements, and we have a pointer that is pointing to null. PTR will have the address of array of the first element, and call is a function name, and that will have arguments as PTR. This PTR value will be transferred to h when it has been called, and we have a for loop wherein we do pointer of h. Pointer of h will give me 1, and I keep on incrementing the address because I know arrays are allocated space consecutively, one after other. So I'm using that as an advantage. By this, I'll show you the code getting compiled. So there's no error, and you can see the values getting printed 1, 34, and 56. Right. So if you want to make a neat presentation, and you can see the values being displayed. So by this, by transferring only 4 bytes of data, address will take 4 bytes. Can you not transfer an array of 300 elements? This is how you transfer 300 elements, by passing only 4 bytes of data to a function. Okay. So let's get into one more example that showcases how to transfer a structure to a function using pointers. Struct hop is as a function. Let me create a function. Let me create a structure, and I hope you understand what are structures. Structures are taking over the disadvantage of arrays. Structure can store different data types: float, b, so char, c. So I said let's define a function. I said void call is a function, and wherein inside the function it is going to take struct hop pointer, anyone of the type of struct hop. I said int main. We are writing the main function, in which we said struct hop type n1 comma n2 comma n3. I took three structures which are of the type struct hop, meaning n1, n2, and n3 will have a, b, c respectively. And how do you put value into the structure? n1 dot a is equal to 34. We did n1 dot b is equal to 90.2300. Okay, so what I do now is I just prepare a pointer, because I cannot send the whole structure to a function directly. I will have to make a pointer. Struct, let's make a pointer. PTR is a pointer. This makes it say that PTR can take an address of whom? We are preparing it to take an address of a structure, struct hop type. PTR will take an address of anyone who is of the type struct hop. So now PTR is equal to address of n1. Yes, n1 is of the type of struct hop, so we can take the address of n1. Next, so let's call the function. I said call, and in call I am sending PTR. PTR is a struct hop pointer. I said my function will take a struct hop pointer as an argument. Let's give the function definition to it. Let's have a variable. Let's take n here. I said let's say you take n, we will say printf percentage d is the value of the structure n1, comma. So let's take a different name so that you don't get confused. Let's take k. When I do k, when I do pointer of k, I will get n1, and n1 internally has a, b and c. So how do you access that is you do pointer of k. How did k get the value? ptr, when it is call, when it has been called, ptr will be transferred to k, and when I do pointer of it, it will get into n1 dot a. And likewise you can see there's no print statement in the main function. I have been printing it on the called function. You see the output here. So let's go and check with the output. Yes, see 34 is the value in structure 1. Yes, it was 34. How did you how did a called function know that this is what is the value inside the structure? Because n1 is a structure that is local to this block. It is a called function. Call is a called function, and it is able to display what is there inside the structure. So this is the benefit of we having pointers. Likewise, there is something called as function pointers. We'll get back to you on the next slide. Thank you.